veracity, and value.
Accuracy of the data that is tested.
Correct. Correct, Aliba. Okay. So what else we discussed? Hadoop architecture. Three main important things of Hadoop architecture. Can anyone tell me?
HDFS, MapReduce, YARN.
Good. What do we mean by yarn?
Yet another resource negotiator.
Good. So what do we mean by map and reduce?
Is a computation point.
Compute engine, correct. We have discussed about map and reduce functions yesterday also with respect to transformations, correct? You all have remembered, right? Okay. Upon Hadoop, we have implemented one more thing. What is that? Just to eliminate the drawbacks of Hadoop.
Spark.
Good. Spark. So in Spark, in the Spark architecture, what do we mean by DAG?
Direct acyclic graph.
Correct. Directed acyclic graph. Okay. What are the two main operations of Spark? RDD?
Transformations and actions.
Correct. What is the third one?
Persistence.
Persistence.
Good. Can anyone explain me what is persistence?
It's about caching.
Good. It is all
Yes,
about the
caching.
caching. When we require the data frequently, we will be keeping it in a cache so that it will be easily retrieved. Good. So where are we now? Okay, what is the full form of RDD?
Resilient distributed.
Resilient distributed data set.
Good. Resilient distributed data set. Okay, so we in RDD we have discussed about transformations and actions yesterday, right? So I have given you assignment. How many of you have completed it? Please share a reaction. I couldn't see much reactions. Okay, no problem. We shall discuss it now. But I know you all are packed, but try to do some assignments and practice the things which we have discussed every day so that it will be easy for you going forward. Okay. I'll be sharing you the notebook every day, what I have discussed for your future purpose. Whenever it is required, you can check all the notebooks along with your notebooks. Okay. If it is with you, it will be in your workspace and it will be easy for you to retrieve it and check it before going to any interviews or something. You have a data, it will be easy. But I'll be sharing you as a link, right? So every time you click on that one, it will be as a notebook only, but you don't know which notebook is which. So try to follow me and create your own notebooks every day, whatever the session we have discussed. Okay. Okay, so let me can anyone tell me how we initialize the Spark session? You can type it actually. If you couldn't say it, you can type it. Jyoti is correct. We are importing it. Good. Okay. So let me tell you this once again today also. Okay. From PySpark.sql, import Spark session. From PySpark.sql, we're importing the Spark session and we are creating an instance and configuring it using this syntax Spark session.builder. It will actually initiate and configure the things which are required. And we are giving the app name as example one and get or create of. If it is already there, it will get it, or if it is not there, it will create it. Okay. From Spark, we have taken Spark context. Why we have taken Spark context means we, in order to create a RDDs, we are taking the Spark context from Spark. Okay. So how do we create any RDD? This is the syntax. SE dot parallelize of. This is the syntax to create RDD. Actually, Spark context deals with the deals with the data at a minor level, like creating the partitions and parallelizing the data set, everything it deals with. So we are taking the Spark context, and in the Spark context, we are utilizing parallelize for creating our RDD. So yesterday we have discussed about one important function, which is gloom. Can anyone explain me what is gloom?
For random partitions.
It shows how
Random
the data
part.
is partitioned in the RDB.
Sorry, I couldn't hear you. Could you please repeat it again?
It shows how data is partitioned inside an RDB.
Correct. So usually random partitions, it is also correct, Jyoti. So usually if the data in RTD, how it will be stored means it will be stored in partitions only. But the thing is, in general, Spark does not allow the worker to refer to the specific parts of RTD. Gloom, what Gloom does is it transforms the RTD to tuples. So it can be easily accessible. What part you want, you can access that particular part. So that is the function of Gloom. So Gloom is a major function. Okay, please remember that one. You can take a note of that one. Like Gloom does transform the RDD of tuples. Okay. Tomorrow I'll be asking you the same question. Next time I want many reactions and answers for this question. So yesterday we have discussed about actions and transformations. So out of all this, the gloom is the major one. And gloom is a transformation function or an action function? Action or transformation, what is it?
Transformation.
Transformation, correct. Gloom is a transformation operation because upon writing gloom, if you don't write colored, it will never show the answer. It will never show how many partitions it has been divided into. So gloom is a transformation operation. Correct. So in transformations, we have two different types. What are those?
Narrow and wide.
Narrow and wide. Correct. Narrow and wide. Can anyone explain me what is narrow and what is wide transformations? Okay, so narrow transformation means they with respect to the diagram, I'll like show you. I'll ask you this question tomorrow also. Please memorize the things. In narrow transformations, the shuffling is not required, and in wide transformations, shuffling is required. For each partition, whatever it is, the answer will come. I mean, no, there is no need to shuffle the things and get the answer for a partition in narrow. But in wide, it is required. Few examples of narrow and wide are this map, flat map, map partition, filter, sample, union. These all are narrow. Just understand by this definition, like shuffling is not required. Okay, where the shuffling is not required, for what operations it is not required. We try to memorize from that perspective. Okay, so just mapping the things. That's all. Union is just combining all the things in the partitions. So there also that there is no need of any shuffling required. So memorize things in such a way. Okay. Okay, so we have discussed about gloom, reduce, and fold. Fold is one of the important operation because the reduce and fold looks same, but in fold we will be having one more parameter which is responsible for changing the answer. Like, see, reduce also produces 10. If you keep 0 here, it will also do the same thing based upon the partitions we have taken here. The result is varying here. I hope you all have good understanding on all of these. Correct? If you want, I will recap. Please let me know you want me to recap or we can continue the class.
Recap once again.
Yeah, sure. Thank you. And your good name, please.
My name is Karthik.
Kartikeya. Okay, okay. Only he wanted to be recap. No one else want it. Let it be. So see, in Gloom, we are taking this complete partition in one, but if we also have one more parameter in this one, that is num slice for parallelize. If we use that num slice, the data will be partitioned into those many number of partitions. So Gloom will tell us how many partitions the data has been divided and how they are into that particular partitions, how numbers are getting accumulated into each partition. It will show us. Okay, if nothing has been given, it will take 8 because according to our Spark context configuration, we have set it as 8 cores. How many cores we are using, it will take those many. So it is 8 for you, me, and everyone. Okay. So how we can check the default partitions means SE dot default parallelism. Default parallelism will give us the number of default partitions. Now that we are coming to the reduce and fold, what do the reduce and fold do? reduce will reduce will give the, see here I have taken the lambda function. There is no need of taking lambda function everywhere. You can create your own function and utilize that particular function here also. Okay, I have taken lambda function because to make you understand easily, but it is not the thing that every time we need to use only lambda function. Okay, so lambda function here we are taken as x and y. So what it will do from the range of 1 to 5, it will create 1 to 4 numbers, and then x plus y means 1 to 1 plus 2. The result will be holded in x and y will be the other number. So this is how it will reduce and it will add on, because here the function is addition. So we got the answer as 10. Okay, so now here in the gloom in the fold one, what do? We have given here one parameter, that is it can be 0, it can be 1, or it can be of any parameter. It can be of any number, but this parameter is very important, because after reducing the numbers, like what this function give is 2. Here we have taken as 2, 4 and 1, 5 in 2 partitions, correct? So 2, 4 will go into 1 and 1, 5 will be in 1. Now that the answer is 15. 6 plus 1, 7 plus 5 is 12. Okay, 12. But the answer is 15 here, because see, when you are partitioning, given the partition as 2, here what it will happen means it will divide the data into 2 partitions, but the whole 2 will again be in one set, right? So total 3 are there. So since it is 1 here, 3 times of 1 is 3. So 12 plus 3 is 15. This is how it changes. Even if you change the value to 2, the answer will be changing here every time. Okay. Now we have come to the map function. So map one, what it usually do, it will just map the things, like with respect to the function what you have given, it will just map. Here I have just taken a simple one, taken x and 67. So for every Jack, Joe, King and SJ, they will get 67. Means it is creating tuples out of a list. Means we here consider this as a list. So it is creating tuples out of that particular RTD. Okay, this is how the map works. Now have come to the flat map. What do the flat map do? Flat map will also do the same thing like map, but this time in a different manner. See, here it has given as the tuples, but here the complete RDD is into only one RDD. I mean, there are no tuples. It is again a list kind of thing. So this is how the result will be flattened and we will get it. So this is what the flat map is. And filter. Filter can be used in any of the things, like whatever the condition you have taken here, it will filter accordingly and it will take it. Union serves the same thing which we have in our SQL. So num2 and num3 I'm unioning, means it is just combining both the RTDs. Okay. Now we have come to the intersection one. It is also serving the same part as like our SQL. It is taking the common part of 2 RTDs. Okay. Now we have come to the important functions, that is reduce by and group by. Reduce by key and group by key. So here in reduce by key and group by key, we have taken a list of tuples. So in RDD, we have taken tuples. So what we are doing, we are reducing by key and with respect to the function we have taken, right? So in this one, x plus y will be happening on both the values. This is considered as x, this is considered as y. So when you merge, when you apply reduce by, it will identify the similar keys and merge it. So here the similar keys are 2, here also 2. So it will merge both of them and this will be the result, like x is considered as this one and y is considered as this one. Coming to the group by, here yesterday when we have taken till here, we got an error because yesterday what happened means when we are collecting the things by grouping by key, we got an error because see, it is expecting something. It is not iterable. The collect function is not iterable, correct? So it couldn't provide the correct answer. But now I have stored that in a result and I have iterated it and printed it. This time we have got the things correctly. So try to memorize this thing, that group by, whenever you write any group by, it is not in a iterable format because in group by, what are all the keys associated with values will come in horizontal way. So for 1 it is 2 and 2 it is 5 and 4 and 3 it is 4. So try to memorize this one. And we also told that this reduced by function answer is equal to this one by mapping the values. Reduced by is equal to group by plus map values of. So here in this function, we have taken some, that's why we got the similar one. If you want to take max or something else, if you have taken the function differently here, it will differ. I mean, the answer will be differing. But the thing is, here, since we have used the sum operation, here also I have taken some to just make you understand that reduce by is equal to group by key plus map values. So I hope you all understood it. Please share a reaction. Yeah, thank you, Kartikeya. Now, yesterday I have given you assignment. Let me quickly open that and show you assignment also. So, firstly, I have given you map partition. Please start taking the notes here. Okay, let me explain you first, and then you can take a note of this one for the assignments. Okay. Firstly, map partition. So I have taken one RDD, and in this RDD I have taken 3 partitions. So what I have done here is I have taken one user-defined function. You all know in Python, we have this definition. I mean, how we define any function, right? So this is the user-defined function definition of. I'm just taking just s of x. This can be of any name you can give s, and x is just a iterable parameter only. Okay, so yield of max of x means what exactly here we are doing means map a partition. By this name, we need to understand one thing. Key. See, the data is divided into partitions, right? So what it will do means it will map based on the partition's results. Means for one partition, what is the result? It will give that one, and the second partition result will be the other. So it will be like that. So here I have taken as 3, right? So first 3 into 1 and next 3 into 1 and next 3 into 1. If we consider like these are partitioned in such a way, then what will be the answer? What I'm taking max, correct? So what it will do max of x? Means within this partition, what is the max value? It is asking. It is 3. In this one, it is 6. In this one, it is 9. But see, here we are not using the return function. Sorry, we are not using return in the function. Instead, we are using yield. Why means, let me tell you. See, here rdd.map partitions of yes means I'm calling this. Okay, let me give some name to this one, else you will partition. No, you get confused. Okay, so I'm calling this function here in the map partitions. So this will come here and it will take x means one whole partition it will take. Okay, in that whole partition, it will yield max of that one. Okay. And again, we have how many partitions? 3 partitions. So for each and every partition, the max function has been applied and it will be generated. The answer will be generated. Remember this thing, we are using yield here because what do return do means it will return just a value and close the complete what we say and it will close the complete function. But what do the yield do means it will pause there and wait for the next result. I mean, to concatenate the results, yield is being used. Since we have 3 partitions, means 3 results need to become. That's why we are using yield here. Please let me know if this is understandable or not. Else I will repeat it again. Okay, I'll take this as yes. So let me execute this one and so here we have taken max. So the result is as we expected. If you want, you can take sum also as a function here, okay? Or whatever you want, you can take the function here. Whatever you want, you can take it here. I will give you time to write notes. Take down this one. This is yesterday's assignment. Execute from your end. Please share a reaction once you have taken a note. Okay, I hope you all have taken a note. And I'm going to the next one, that is repartition and collapse. So what does this mean? So in the name itself, repartition, it is saying that we need to, when we need partition again, then that time we are using this repartition. Means if the data is not partitioned during the time, by the time it has been initialized, we can partition it using this repartition function. Okay. So here I am taking the repartitions as 4 and in this one. So let me see what will be the answer for this one. See, I'm printing only the repartition one to just check the answer. So we have taken into 4 partitions, right? 1 to 8 numbers. What it has done, 3 into 1, 3 into 1, 4 as 1, and 1 empty partition is also created. Okay. Now the college. What do this mean means? It is also the same thing what it has been here. Like repartition and college serves the same thing. Let me execute this one. So in this also, it has created into 3 partitions. Okay. So when it is not created, but ideally, what it will happen means this repartition is more complex, and when you are dealing with larger data sets, and it is bit like taking more memory. So many times we will be doing is we will be using collage. This repartition will shuffle the data and do the repartition. The shuffling in the main like it will take more nodes. Think from the big data perspective. So it is very costly when we have used the repartition. Okay. So the collage is also serving the same purpose. So mostly we'll be using this one. Okay. Please take a note of this one. Please let me know if you have any questions. Please pause me. If you are not saying yes or no or nothing, I never know how, how you are understanding or what is your question. Unless you don't ask me, I don't know, right? From tomorrow onwards, before coming to the session, please revise the things what we have done till today. Like means I have shared you the important PPT slides and all, right? Just go through them every day. Okay. Go through them every day and see the notebooks every day. Today we have session 3, means till session 2, you need to revise the topics and you need to come to the class. Okay. Because every day the class will be in continuation way only. Today I have recapped each and everything. Maybe from tomorrow it might not be possible because when the syllabus is completing, when for recap only it will take much time than to cover the topics. So try to recap from your end every day. Okay. I hope you all have taken a note of this one. And I'm going to the next one, which is very, very important one. That is aggregate. I'll be moving to this one now. Please share a reaction once you have done, so that I'll start the next one. Yes, someone. Do you have any doubt? 4C7? Okay. You are just giving like, okay, that's fine. Okay, I'm going to the next one, that is aggregate one. So in aggregate, let's see. Aggregate function. Let me explain you this particular thing and then I'll explain from the top. Okay. What this aggregate function, what this aggregate operation will do means it has three parameters. First is this initializer, and second one, I have taken random values like T1 and T2, but what these exactly means, see, if I hover on this one, we have got something on the top. Definition of aggregate, zero value and SEQOP means sequential operations, and other parameter is COMB combination operations. Okay, combining operations, let's say. Okay, so understand what all these are. Means three parameters we have. One is zero value, sequential operations, and combining operations. Okay, what this will do means we are calling a functions inside this one, means sequential operation. Okay, perform the sequential operation on whatever the things we have taken. So this in this T1, I am taking the lambda function again, and I'm taking the very basic one, that is addition. So what it will do, it will add up both the things. Okay. See, firstly, RDD equals means what it will take means this one. Don't confuse where this has been initialized. I have initialized here means 1 to 7 numbers will be there and partitioned into 3. This will be the result. I mean, this particular RDD we are taking here. Okay, for our aggregate function. Now that we are taking value as 0 and T1, in this we have defined a lambda function which is sum, and T2 I have taken as x plus 1 plus y. So let me explain to you again. See, this what it will do means it will take each and everything and it will give the result as is. Okay, means addition of all these numbers. Okay, but they let me execute it and show you. 31 as a result. Okay. So the aggregate, when we print this aggregate, the result of this one is 31. Can anyone tell me what is the sum of all these numbers?
28.
28.
Right. Okay. So the sum of all these is 28, you're saying 3 plus 6, 10 plus 15 plus 6, 3, 1 and yes, 28. Okay, so 28, but the aggregate has resulted 31. I will explain you why it is like that. Okay. Now, when you do the second one, do you think it will operate as the first one only? Means adding just +1 to all of them will give the answer to this one? No,
We
right?
have
Yes, yes, you're saying something. Please continue, Kartikeya. If you're saying something, please continue. Okay. So what is the T1 answer will be like 28, as you said. But what do the T2 will produce? Means ideally, if we reduce this, then the answer will be the different one. Let's see. So here the answer is 34. What it has done, it has added 1 to all of them, like x plus 1 plus y. Every time it has taken two values, it will add 1. 3 plus 1, 4 plus 7, like that it will add. And it has given the result as 34. But here if you see, the result is 31. Means when here I'm taking just a not tuple value. I'm just taking the list of values in RTT, right? That's why I have got only one value. But if you consider this as a tuples, then you will be getting the answer as tuple only. Since I have considered as list, it has given me only one value. And this answer will be the answer of T2. Okay. So what does here it has done means in T2, for in Colas we have taken 3 partitions, right? So what it will do means 3 partitions are there. So X and Y are considered as partitions. Okay. X will be the result of one partition and Y will be the result of another partition. Okay. So if I say 1 is in one partition, 2, 3, 4 are in another partition. So what is the result of 1 means 1, 2, 3, 4. What is the result of this one? 9. So 1 is the result of one partition, 9 is the result of another partition. 1 plus 1 plus 9 is 11. So 11 plus again, see, it has not completed yet. We have one more partition here, right? So 11 plus 1 plus again this partition value. 6 plus 5, 11 plus 7, 18. 18 plus 1 plus, what is the result of this one? We just discussed. 1, 2 plus 9, 11. 11 plus, wait. This is the, for the first partition when we have done, it is 11. And for the second one, it is 7 plus 6 plus 5, 18. 18 plus 11 is 29. 29 plus 1 is 30. And for the whole partition, it is plus 1. Right. See, when we have taken this one, the result of one partition will be stored in X and the result of another partition will be stored in Y. So you do some from your end and test it. Okay. How many do we have? 3 partitions. So one partition will go in X, another will go into Y, and addition of that one plus 1. And similarly, second value plus third value will be the second one. Okay, this is how it works. Instead of me explaining you this one, try to validate from your end and ask me questions. Take a note of this one. Has everyone understood what this aggregate function is? It actually yielding the T2 value result because I have taken the list as a RDD, but not the tuple. That's why we have got only one value. But if we have taken the tuples, then we will be getting the answers of both the sequential operations and also the combination operations. We can still get it. Okay. Has everyone understood what I told you about the aggregate function? Or do you want me to repeat it again? Okay. I'll take this as yes. Please take a note of this one. We shall go to the next topic. Please share a reaction if you have taken a note of this one. We shall go ahead. I hope everyone has taken a note of this one. I'm going to the next one. We have completed this one. So now we will be entering into the data frame tests. Okay. So data frames are also the important topic in our PySpark course. Okay. So how we have taken RDD similarly, but in a different syntax, we will be taking the data frames also. So what are the differences between the RDD and data frames? If you see, RDD is like what we are taking RDD as a list of the data. Now we have taken like a list, but see, the tuples can also be taken into the RDD and all. But the data frames. When you see here, the answers will be for all these will be in this format, partitioned format. But when you come to the data frames, it will be in a tabular format. This is in a partition format and data frames outputs will be in a tabular format. It is just like our relational database tables. It will just look like. Okay, so let me explain you the Databricks data frames, PySpark data frames, and I will give you time. Okay, don't worry of writing this in hurry. Let's create a, okay, for see, creating a data in frames is what the data frame is. Try to take it in like how you can betterly memorize it. You can take it like that. I'm creating data. So I told you it will be in a tabular format, right? So let me take names, IDs, and age. Sorry. This is the data I'm going to create. Created data of your own. I have created data, and similarly, I'm also creating a schema for this data. What we have discussed, these are IDs and these are names and these are ages, right? So the schema will be like schema is equal to ID, name, and age. So we have data and we also have schema. Now we shall see how we can create a data frame. So for creating a data frame, we need to take from Spark. Spark dot create data frame. From Spark, I'm taking the data frame function and I'm assigning data equal to data, comma, schema. These two are the default things in create data frame function. These two are the fixed parameters, data and schema. If you want, you can change the names here and you can edit the same. Okay. So let me execute this and show you. Create data frame, what I'm expecting. Schema. Okay, okay. See, the data frame has been created, but how we can in RDD we have collect function which would collect the partitions and show us, but in data frames it is df dot show off. This is the one which helps us to retrieve the data. So this is our data which is in tabular format. See here, it is in a tabular format and above whatever we have discussed is in a partitions, in a kind of list. So quickly create a data frame from your end. The data can be of any value you can take. I'm just creating it with ID, name, and age. It is up to you what you want to create in data. Okay. The schema, I have taken this as ID, name, and age. That's all. If you want to create, you can take salary here and like 4,000, 5,000 something, you can take it and give it as a salary. I will show you one more thing. See here, if I click on this one, I got the data type of ID, name, and age. See, I haven't assigned any data type to this one. ID or name or age, whatever it is, I haven't assigned anything. It has taken automatically. Upon giving the names, it has the capacity to analyze the things and take the data types internally. Upon creating the data frame, you will be able to identify the data types. Okay, so see in this particular example, I have taken ID, name, and age without giving the data types. But usually, now, when we are dealing with larger data, it is not possible because you need to have a fixed columns and their data types. Unless you don't have it, every day the data is changing. It will be hard to analyze the data. For be it in any language, it is hard to process the data. So since we are doing for the smaller data set and for examples, I have taken like this, but in real time, we will be doing it in a fixed schema. I will show you how we can take a fixed schema and how we can create a data. We can create a data frame with the fixed schema at all. Okay. Remember this one. The data frame has been created using the function create data frame of, and we have two parameters. One is data and the other is schema. So based on that one, we have assigned the values in the same way. And one more thing, in RDD, we are taking it from Spark context, SC dot parallelize of we are taking. But in data frames, we are taking it from Spark directly. Okay. The Spark context and the RDDs are at the granular level when we are dealing at a granular level. But in data frames, it is not that granular level. Like, see, when you create RDD, you could see the partitions, everything. But here in the data frames, we will not be seeing all those partitions, etc. Okay. I hope everyone has taken a note of this one. I will go to the next one. We have a function to convert the RDD to the data frames. Let's see that one. Okay. Let me create a empty RDD. Data. Let's take the empty one. And I'm taking the RDD also as empty RDD. Let me initialize the RDD first. SC dot parallelize of without giving anything, I'm just giving this. So this is an empty RDD. And now I'm converting this particular RDD to my data frame underscore empty. Just create it like this. And now what we can do, how to convert is just give the RDD name dot to df of. We have this particular function to df of, which helps us to convert the RDD to data frame. Let me execute this one. See, this is expected. When you try to do something which is empty, it will always give this only, right? So this is how we can convert the RDD to empty RDD. I have created this just to add columns and all later. Okay. Now let me tell you about the schema which I have discussed earlier. Sorry. Take a note of this one. Empty RDD, initialize one empty RDD and convert it into the data frame. Whatever, even if you print also, it is stopping here because it is empty. Moving to the next one. So as I told you about the schema with data frames. Okay. Have you ever heard about the struct type and the struct field? Anyone can answer this question. Have you ever heard about the struct field and struct type? Okay, no problem. Let me explain you what is the struct type and struct field, because in schema we are using that one. That's why I'm explaining that one. Struct type is a collection of a struct field. What do this struct field do means it will just take the column names and their data types, and if it can be nullable or not. In our DB also, whenever you create any tables, it will ask you, right, for every column, what is its data type? And key, we have keys in database, right? Primary key, foreign key, like that. Primary, unique, not null, all this we will be having. If it is ID, we will be creating it as a primary key or a unique key, something like that. So here in schema also, for struct field, we will be giving if it can be nullable or it cannot be nullable. So it is like that. Okay, let me create fastly. Columns is equal to, I'm taking the struct type. Struct type of struct field of, let me consider name and salary. Okay, name, I'm giving only two. Name will be of what type? Usually we have string, correct? So string type of, and it can be nullable, right? So let me add a Boolean value here. Okay. So I will be giving another struct field. This time it is salary. Salary is of integer type I'm taking. And salary can also be nullable I'm taking. So this is how we are creating the schema for any particular table. Okay, so in this schema, I have taken two, name and salary. So now I'm creating this one. So we have already created one empty RDD in the above, right? I'm just creating empty RDD with schema. Let's see what it will give us. Okay. With the schema. create data frame of MTRDD as data and schema as columns. Okay. Let me execute it. Struct type is not defined. Okay. So before coming to this one, we need to import. See, from here onwards, while working with the data frames, we need to import everything. In our RDD, we have taken only Spark context, and in Spark context, we have utilized so many functions, right? So likewise in Spark also, we need to take it and utilize it. I'm taking from, see, for whole notebook, if I import once, it will be used throughout the notebook. No, but it will be initiated for each and every notebook every time. Means for this complete whole notebook, if I initialize it here, it can be utilized everywhere in the notebook. Okay. But when you create the new notebook, if you don't initialize this one, it will not work. This is for data frames. Okay. See here, it is giving me everything whatever I have. Now I'm taking from SQL types, importing the struct field and struct type. And we have also taken this integer type and string type, right? So here it is string type. Here it is a spelling mistake, FIELD. Takes one to do, but given three struct type of struct field, string type, and whether it is nullable or not. What it is expecting actually. Okay, this has been used here instead of using it here. Create data frame. Oh, okay. See, it has created now. So while creating the data frame, we should be always taking the spark.create data frame off, and for MTRDD, I'm taking the columns as a schema. So see, from the bigger perspective, what it will happen means every day to process your data, every day a file is being generated. For example, today we have, let's say for Amazon, for complete today's sales, how much it has been, someone has ordered something, whatever it is, cancelled, whatever, all the data will be coming into in one file, and we need to operate on that file. So sometimes the file may not come due to some issues. So in order to process the data, what we do with the fixed schema, we will. Yes, Amrita. Do you have any questions? So at that moment, we will be creating a file with the fixed schema and we'll be processing it. When the file comes, we will reiterate the process and we'll be doing it. So this is how this is being used. Use case of this one, I'm just telling you. You can take a note of this one. Remember, this has to be done for every notebook when you create a new notebooks. Okay. And these struct field, struct type are like in schema. Struct type is a collection of struct fields. Struct fields are actually the name of the column and the type of the column and the value, like if it is, it can be nullable or it cannot be nullable. It is like that. Okay. I hope this is understandable to everyone. If not, please unmute yourself and ask me questions. Because we are into the important topic called data frames. I hope you all are taking down the notes. We have seen how to create a data frame using create data frame of function. Now we are using 2df function to create. No, we have completed that also, I believe. Yeah, here we have created it, right? Yeah, that is also done. So we can move to the next one. I hope everyone has completed. Now we are doing with row number. So here, if you see, let me here we have created one data frame, right? So what are rows here? This complete one is a row and this complete one is a column, right? So in data frames, we have row functions and also column functions. Be it anything. Okay. Let me create one more data frame completely with data and also the schema with fixed schema. Okay. This time how we can create a schema. We can create a fixed schema using this one. This one is ID again, and it is of integer type. And this cannot be nullable. So I'm taking it as false. Okay. Data frame equals to spark dot create data frame of data, columns. In for displaying the data frames, we are using function show. this is for fixed schema with data. Please take a note of this one, or else you can create of your own data and schema. We have seen how to convert an RDD to data frame, but we have seen which is an empty one. We will be seeing a few more going forward. Okay. Once this is done, I will be explaining about the rows. Row functions we have, column functions we have, and in rather than in row functions, we have more in column functions. So I will be explaining you few of the column functions, and you can take an assignment and do the remaining column functions. Okay, it is very simple. See, rather than because today it is easy because you have already learned about the actions and transformations, right? So it will be easy for you now when working with the data frames, because now or the other way, we will be using few of them again and again in data frames, be it in RDD or in data frames. We'll be using those operations. Okay. I hope you all are taking note of this one along with me. If you want to check the schema, you can check it from here, or you also have a function print schema of. This is to purely print the schema of the data, and this is to show the complete data. See, there is a limitation for show. Okay, what it will do means in show, when you write a show here, it will take, see, this is a very smaller data set, only 4 rows we have given. But if it is beyond 20, it will not display. So there are limitations for show, because in this console, no, it will display only 20, even though you have more than 20. It will take only first 20, like that. Okay. And if the name column, whatever the string types are there, if the names are beyond the character 20 characters, it will cut to 20 and it will take till 20 characters only for the show. Okay. I hope everyone are following up with me. We are going to the next row functions now inside the data frames. Okay, so how we can color, see, still we can use the colored one here also. For row, I'm taking like df dot color row. It will give you, okay, I need to print it. But I don't think it will print it. Huh. See, it has given in a format like list, right? Let me iterate it, so that it will be easy for you. It's in row. See, when we use the iteration here and we can get rows separately like this. So this is how we can iterate over rows of the data frames. Okay. So we have filter function. If you have yesterday's class, if you have remember it correctly, in yesterday's class, we have also discussed about the filter function. Now we shall see how it is applicable here. Okay. Let me take the df dot filter of, I'm filtering whose salary is greater than 4,000. Okay. Filter dot df dot salary. I have given it in a small case or uppercase. Uppercase. Salary greater than 4,000. Let me store it in one more. df2. And let me print it. df2 dot to off. I got the one who is having salary greater than 4,000. So this filter particularly is applicable to the particular column also here now. And these are very small functions. So that's why I'm not giving you much time. Try to do it quickly. I have initialized the data frame only once here. Here I have taken the data frame now. So I'm utilizing the same data frame for all my functions, for rows and also the filter one, and going forward whatever we are. If there is any need, I'll create a new data frame. If you want, you can create a new data frames of your own for each and every function. Okay. I hope you have taken it. Now I will be showing you one more thing. While creating the data frame, there is one more thing which we have left. Let me create it here. Okay. So this is also a one way to create a data frame. df1 is equal to r dot range of, like we have range of function in parallelize. If you remember this, I am taking the same thing here, but this time spark dot range of directly I have taken dot to df. And let me name this numbers. Let me print it. Okay. So this is also one way to create a data frame for taking the range of numbers like that. Okay. If you want me to pause at any moment that if you feel I'm going fast, scrolling it down, please let me know. Okay. I'm going to the next one. I'm taking the same one. Let's see how it will be if we have taken it. We have to collect of when we print it instead of iterating it, we have got rows something like that, right? Let's see the difference between when we print it directly, it is coming as list, but there it is a different one. Give me a moment. Sorry. Okay, so now where are we? We are in row functions and we have seen the filter one also. And from this one, rows also, from rows, we can take the first two rows, something like that. Df dot using take function, take two of. It will take only first two of them. If you want to print it, you can print it in a different way. No, print will also be in the same way. Try to show it. These are very small functions we are checking. So it has no- You can iterate it taking this also, like I have taken it above. And now I'm going to the next one. In today's class, we have discussed about two things. One is row and also column functions. In rows, we have only few of them which we have discussed now. But in column functions, we have many. These all are column functions. Let me zoom it. Take a screenshot of this one. I will also share you, but please take a screenshot of this. Because you need to do assignment of these by tomorrow. I'll be explaining you few of them like descending, sorting, and alias, ascending. You already know. See, these all functions when you see alias means to change the name of any particular column, this is used. Okay, name of also returns same as alias and ascending to return something in ascending order. It is the one returns the null values first, then the non-null values um, for this one. And if you keep it as last, then it will take the null values at the last. So please take a screenshot of this one and read it at your end before coming to the class tomorrow and try to do assignment on few of them. Like which all are I have taken today, no need, but the remaining you need to practice upon yourself. These all are very small functions. Okay. I will explain you few of them now. Between I hope everyone has taken a screenshot of this one. Is anyone having any doubt? Okay, I'll take this as so starts with, ends with. These all are the also the functions which we have. You might have encountered some in Java or a few ascending, descending. you can correlate with SQL or the other languages what you have known. Python, you know, right? You can correlate with them. Substring, it will be there in all the programming things. When otherwise drop fields by with fields, we will discuss a few of them um, which are difficult. I'll let you know. Okay. Now, I hope you have taken the screenshot. Now I'm going for the column functions. So we have already taken a data frame using those data frames only. Now I'm going to take like see in column functions now. Now I will be discussing about LIT now, which means literal. Okay, one of the most important column function we can say. Okay, from the df underscore add equals to df dot to add any column. I'm using with column of, and I'm giving the column name as country, comma, literal function here, because when we use literal function here, what it will do is it will fix the value throughout the column. So that is the use of this one. Now I'm printing this df dot flow of, sorry, lit is not defined. So whatever it is, make a habit of importing it first before using. From PySpark.sql types. Import. No, from types it is not there. That's why it is not showing up. Let me take it from functions. Let's see if it is there or not. Let is there. See, I'm executing. So I have executed df only. That's why we didn't get the column. Let me execute it with df add column. See, the country has been added and the country is USA. And throughout the column, the value is fixed. So the major here in the column functions, what we have taken is, firstly, we have taken with column of function to add a column, and then we also used this literal function, which helps us to add a value which is fixed throughout the column. So here in this one, we have taken two. Okay. I hope everyone are taking note of this one. See, after I execute it and I explain it, try to initiate writing from your end. Okay. I hope everyone are taking down the note. We have seen the row function, which is very in row we have filter, and we have taken take function. and we have iterated the rows with our functions. One of our user-defined functions, we have taken it. When coming to the column functions, we have numerous column functions. That's why we are discussing few among them, and later you will be doing it as an assignment. I hope everyone has taken a note. I will be moving to the next one, which is column of. So what it will do means, just you can just identify this one. Okay, DF by understanding the name itself, you can think what it will do. Just column of. If you select, see, I'm selecting here, select of from this above data frame, add column. I'm selecting the column of. Let me select name. Okay. Name. Then I will be writing. So what I have taken here, I'm taking select of column, which column I want. I have taken and writing the show off. So in order to output it and executing this one, column is not defined. Okay. Let me put it here. We have names here. See, every time I try to execute something in this one, it is asking me to import it first and then use it. So try to be aligned on this one. Every day when you start any new notebook, try to import all the required, like struct field, struct type, integer type, in string type. All these are major and it will be needed every day. So from PySpark SQL import functions, you can will do one thing. Yeah, I'll import the complete functions. No, wait. If I import function, again I will be needing to import them separately. So let it be like this only for today. Okay, so here we have seen the column function. Now we will be seeing the sorting as we discussed. See, the syntaxes will be similar. Again, df underscore add column of from this data frame and selecting first select the data, which data you want. I want data frame dot. I want these IDs to be in ascending order or descending order. Okay. df dot id dot ascending off. And just give show off. You cannot generate the code for the expression and put df dot id is in capital only, no? Then why it couldn't take it? Let's see. df dot id generate the code of expression false. Oh, okay, okay. So what I have taken the ID, the nullable values as false, right? So it cannot print that one. It is saying, okay, I'm taking salary instead of ID. We have taken, now generate the code for the expression input one string is true. Assembling nulls first. Okay, let me use this function instead. Ascending nulls last. Cannot generate the code for the expression one ascending nulls last. Select okay. Not not select. It should be sort. So name dot. So now it has sorted with respect to name. So the thing is not with respect to the null characters and all. It is about I have taken select instead of sort function. That's why I got error. So try to take a clear note of this one. For sorting, it is sort, not select. Likewise, you can use all the functions here for all the sortings, okay? So here today we have discussed, I hope you all have taken a note of this one. We have only 5 minutes left. So what we can do is, I will tell you what you can do as assignment here. Okay. So you can take assignment for like, or like substring. You already know, right? You can definitely do this one. Substring, like, are like, and is null, is not null, get item, get field of. See, get field of is nothing but it is taking the field from the struct field only. But I will explain you this one because there is something which I need to explain you. In while defining the schemas here, see here I have given you the schemas, right? This struct field can be nested one, means for name you can have first name, last name, middle name like that, right? So again, you can open the struct field inside the struct field and you can give the values here so that it will be a nested struct field. So we can nest it. I will show you that particular thing tomorrow. Okay. So don't go for get field. Like, are like, null, is null, substring, when, and descending you already know. Bitwise all operators you can do it, and or XOR and casting. Casting also you already know. It will just convert the data type. If it is whatever you want, it will be converting it. Okay. Starts with, ends with. You all can definitely explore all this because these are all not very tough and which are not understandable. Okay. You can try of your own of all of them. I will be continuing today's class tomorrow for nested structure fields, and also I will be telling you the get field, get item also I will be telling you because there is a nested class in a nested field inside a field. So we shall take that one. And between also I'll explain you. This bitwise operators, you can try it. If not, if you couldn't understand anything out of this one, you can ask me. Sometimes it is also the easy one. You can try it of yourself. Okay. Just try all of them. You have taken a screenshot, right? try to implement all of them, each and everything. Even if I tell you or not tell you, try to execute all of them and ask me questions tomorrow. I will be explaining you those who are having any doubts. If not, I'll not be explaining all of them like today, because see, uh, these all are very small functions. You can do it of your own. Okay. I hope this works with all. Correct? Yeah, thank you. Thanks for your reactions. I hope you will be doing the assignment today. Anyone is having any questions, please let me know in today's class. In today's class, let me go above and see what we have discussed. We have discussed yesterday's assignment map partition, tree partition, and college. This map partition is mapping the partitions. You can identify like that one. And repartition is if the partition has not been initialized, then you can repartition it by creating another RDD, and college is also serving the same purpose. And this aggregate function, see, aggregate function is little bit tough when I explain you, but when you execute it and when you try to take answers of yourself, it will be easy. Okay. And coming today, we have discussed about data frames, creating a data frame. And we in this schema, we have not declared any of the data types for any of these, correct? So in later, we have taken how to convert RDD to data frame. Try to convert RDDs which you have created and convert it into DF. Okay, and let me know if you face any issues. Okay, while converting the RDD to data frames, you can convert any RDD to data frame. Okay, schema with data frames. So creating schema using struct type and struct field. We have checked today. And using struct type and struct field, we have got to know that if we use something like struct type to declare a schema, then this is a fixed schema. So we have checked that one, and we have checked one more function which can be initialized, which can be converted it into the data frame, like taking the range from the spark dot range of 1 to 9 and converting it into the data frame. And again, we have checked the rows, how we can take the rows. I mean, how each row can be collected separately and how we can iterate it throughout the function, throughout the for loop we have checked. And we have checked the filter function, collect function, and take function we have checked. Now coming to the column functions, we have, see, every time when we are using something, we for column, we have taken the functions from functions. PySpark dot SQL dot functions, we are importing LIT means literal and this column. And above, when we are using these schemas, what we have imported struct field, type, integer type, string type. So we have discussed all of them. So tomorrow I will be asking you questions on today's class. So be prepared. Before you come to the class, just revise each and everything and come to the class so that it will be easy for you also to get it continued and easy for me also. Okay.
Okay, madam.
Yeah. Okay, sir.
Yeah. So anyway, thank you, students. Okay.
Thank you all.
Thank you, madam.
Good
Yeah.
night.
Yeah. Good night to all.